Ever found yourself pondering about the frequency pattern of dice rolls? It's a question that might seem unusual, but is quite fascinating. You see, the world of dice rolls is a microcosm of randomness and probability, a dance of chance that's been enticing gamblers and mathematicians for centuries. Now imagine charting 10,000 random dice rolls. Yes, you heard it right, 10,000. Studying the frequency pattern of each number rolled. It's not just about the numbers 1 through 6. We're talking about the sum of 2 dice here, so the numbers range from 2 to 12. Intriguing, isn't it? In this video, we'll delve into this world, exploring the Elliott wave pattern of even and odd numbers, the numbers above 7 and those below. We'll dissect the intriguing patterns of numbers 2, 3, 4, 10, 11, 12, 7 against numbers 5, 6, 8, and 9. So, are you ready to dive into this dicey journey? Let's roll. Imagine rolling a pair of dice, not once, not twice, but 10,000 times. Quite a task, isn't it? But guess what? We've done it for you. In this grand experiment, we've taken 2 dice and rolled them 10,000 times. Every roll was recorded, every number documented. We've ensured complete randomness in the dice rolls, leaving no room for human bias or error. From the rolls, we've created an Elliott wave pattern, a fascinating model often used in financial markets, but this time applied to our dice rolls. We've mapped out the even and odd numbers, those numbers that climbed above 7, and those that stayed below. We didn't stop there. We also compared the frequency of the numbers 2, 3, 4, 10, 11, 12, and 7 against the frequency of the numbers 5, 6, 8, and 9. The aim? To detect any patterns, any hidden rhythms in the chaos of chance. Now that we've rolled our dice 10,000 times, let's see what patterns emerge. Here's where things get exciting. With our data in hand, we begin to see patterns that might surprise you. Let's start with the frequency patterns of each number. You might think that all numbers should appear with the same frequency, right? But it's not so simple. The Elliott wave patterns further deepen this mystery. When we look at even and odd numbers, we notice a rhythmic pulsation, a dance between the two groups. Now let's shift our focus to numbers above and below 7. Here we see another pattern, distinct yet harmonious with the first. Let's get more specific. We grouped numbers into 2 sets, 2, 3, 4, 10, 11, 12, 7, and 5, 6, 8, 9. Against all odds, each of these groups also showed its unique wave patterns. Remember, these patterns aren't just random fluctuations, they're the hidden music of chance, the secret language of randomness. So, we've discovered some intriguing patterns. But what do they mean? So, after 10,000 dice rolls, what have we learned? We've discovered that even and odd numbers, those above and below 7, they all follow an Elliott wave pattern. This pattern shows a rhythm to the randomness, a dance of probability that is as mesmerizing as it is mysterious. We've also found that the numbers 2, 3, 4, 10, 11, 12, and 7 have their own unique frequency pattern distinct from the numbers 5, 6, 8, and 9. This insight challenges our perception of probability, nudging us to rethink how we approach the notion of chance. The patterns we've unearthed don't necessarily provide a predictable outcome for each roll. However, they do hint at the underlying mathematical truths that govern the universe. The seemingly random is in fact a tapestry of intricate patterns waiting to be discovered. And there you have it, a deep dive into the fascinating world of dice rolls. Remember, the next time you roll a dice, there's more to it than just luck. Now, let's take a closer look at the actual Elliott wave charts of our 3 distinct groupings from our dice roll experiment. First, let's consider the chart for even and odd numbers. As you can see, the peaks and troughs of this chart represent the alternating frequencies of even and odd outcomes. Notice how the waves ebb and flow, reflecting the inherent rhythm of randomness. Now onto the chart for numbers above and below 7. The oscillations here are more nuanced, with a distinct pattern that seems to dance along an invisible line. It's a beautiful representation of the delicate balance between high and low outcomes in dice rolls. Finally, we turn our attention to the most intriguing chart, the unique frequency pattern of numbers 2, 3, 4, 10, 11, 12, and 7, distinct from the numbers 5, 6, 8, and 9. This chart almost seems to tell a story, doesn't it? Each number with its own pattern, yet all part of the same narrative of probability and chance. These charts visually represent the fascinating patterns we've discovered in our dice roll experiment. They paint a picture of the universe's underlying mathematical truths in a way that is both mesmerizing and enlightening. Next time you roll a dice, remember, there's more to it than just luck. There's a symphony of patterns playing out with each roll. Having seen the visual representation of the Elliott wave charts, let's delve deeper into the fascinating world of numbers behind them. In this scene, we're going to explore the mathematical elements that govern the patterns we've observed in our dice roll experiment. First, we take a closer look at the chart for even and odd numbers. You may have noticed the rhythmic oscillations, but did you know this is a direct reflection of the law of large numbers? As more dice rolls are made, the difference between the number of even and odd results tends to zero, resulting in a balance that gives us this alternating frequency pattern. Moving on to the chart for numbers above and below 7, the nuances become more interesting. This chart depicts the principle of equiprobability, where each outcome in a set of outcomes has an equal probability of occurrence. It's this principle that creates the delicate dance of highs and lows we observed. Finally, let's examine the unique frequency pattern of numbers 2, 3, 4, 10, 11, 12, and 7. The story this chart tells is one of probability distribution. Each number on a dice has its own probability, contributing to the overall pattern we see. So as we can see, the mesmerizing patterns in these charts are not merely a result of randomness, but of mathematical laws and principles. Remember, each time you roll a dice, you're not just playing a game of chance. You're participating in a cosmic dance of numbers, governed by the unchanging laws of mathematics. In the next scene, we'll explore how these principles can be applied beyond the realm of dice rolls.